Okay, so now that we know that life on Earth is carbon-based, know that those carbon molecules are one thing that we can look for when we start looking for life beyond Earth. And that's what we're going to talk about now, life beyond Earth. And we're going to start by looking close to home at life, or the possibility for life, in our solar system, the 8 planets and moons around the sun. And then in the next video, we will move on to life beyond our solar system, life around other stars. So is there life in the solar system? Haven't found it yet, but that doesn't mean that we quit looking. There's a whole set of astronomers called astrobiologists, and they look for life. They look for those protein molecules made of carbon that we talked about before. And they look for all the things needed for life. And again, we are biased because we're going to be looking for things that are needed for life on Earth. But remember, that's all we know. That's the only kind of life we know of. So we have to start somewhere. We have to narrow down our search. So we're going to look for the things needed for life on Earth. And those include water. Heat. We are in a completely frozen ball. We did not have any life here. Those Snopes elements, right? Carbon. And we look for an atmosphere. It turns out our atmosphere is pretty important. Protects us from radiation, gives us air to breathe, all that good stuff. So as we go out from Earth looking for life, these are some of the key elements that we are going to look for. Liquid water in particular, a source of heat, particular elements or molecules, and an atmosphere. So the best planet to look at, and people have thought this for a very long time, especially if you look at your sci-fi, is Mars. Right? Close to home, sort of most like Earth in a lot of ways. It is the best candidate, best place to look for life among the planets. So best candidate for life of the planet. Briefly, let me just say Venus is too hot. Toxic atmosphere, crushing pressure, not so good. The gas giants have no surface, so Jupiter and Saturn are out. Mercury is too close to the sun and also has no atmosphere, no water. But Mars does have an atmosphere. It's pretty thin compared to ours. And by the way, if you take Astronomy 101, you'll get a lot more in depth about the planets and some of the moons we're going to talk about. But Mars has an atmosphere. It used to be thicker, we think. And it does have water. Right now, we can only confirm that that water is in the form of ice. But we have very strong evidence that it used to be liquid. Used to be liquid. And so that used to be tells us, well, maybe there used to be life as well. Okay. So what's some evidence? Well, oops, and that's water ice, by the way. Mars does have a little bit of ice near the poles. Most of that is actually dry ice, carbon dioxide ice. But we've seen ice under the surface. And evidence that that ice used to be liquid comes in the form of these river valleys. They're dry now. It's too cold there, and the atmosphere is too thin to really keep that liquid water. But it looks like there were floods and rivers all over this planet. And there's good evidence that there's still a fair amount of ice under the surface. So we have water, we have atmosphere. It used to be warmer. Um, so people look to Mars and say, well, maybe there was something there, or maybe there's still something surviving there. But we have no current evidence for life. I do want to tell you about one sort of close call, I guess. Um, People got really excited about this meteorite right here that I'm showing you. Just looks like a rock, right? This meteorite was found in Antarctica. Great place to look for rocks because they stand out on the snow. And we know it's from Mars because of what it's made of. We have a pretty good idea of what a Mars rock looks like versus a moon rock or an asteroid or something. And when they examined it with a microscope, they saw these things. So here on the left, you see these little wormy type things. They are very, very small. 100 nanometers is tiny. That's like shorter than the wavelength of light. Okay, and they compared it to something on Earth that came from a riverbed here. And we know these things, or we're pretty sure these things on Earth are formed by life, that they are little pieces of cells. And so that people got really excited. Oh, these things look just like the Earth things. The Mars things look like the Earth things, so maybe there's life. But it didn't go very far. The more that scientists looked at this rock and compared the samples, the fewer and fewer people thought that this was actually really evidence for life. So this was back in the 90s, but today most people don't really put much credit to this. Scientists don't give up, though. We continue to look when probes and rovers go to Mars. There's often a component that includes looking for some evidence of life, especially for past life. We focus now pretty much on looking for fossil evidence, and that's what that was in the rocks too, right? Those were not like live creatures. Those were just fossils. Or really tiny life. We're pretty sure that there aren't big aliens on Mars. We've surveyed it enough by now. But there could be fossils or microbes under the surface. We know that some of this microbiological life thrives in weird conditions on Earth. Very cold, or can last for a long time without really doing much. A lot of Mars is like Antarctica, where we do find evidence for life. So we go, we dig, here's some of that water ice under the surface of the dirt. We look and we see what's there, but no evidence as of now. So that's Mars for you. Next, we are going to move on to some moons, because we ruled out basically the other planets, but there are some very interesting moons. And these are all moons, not our moon. Our moon does not have an atmosphere or much water to speak of. But the moons of some of the giant planets, Saturn and Jupiter, are pretty interesting and places we would like to know more about and visit. I'm going to tell you about 3 of them. The first is Europa, and I'll have a couple of videos that you can learn more about these moons as well from other YouTube sources. Okay, so Europa is one of Jupiter's moons. And why is it interesting? Well, look at its surface. Its surface looks a lot like a frozen ocean. And that's exactly what we think it is. That it is a layer of water ice which is covering up a deep, deep ocean. So liquid water. So, and a possible ocean. So look at the surface here. From South Louisiana, you probably haven't seen frozen ocean, but what happens, the water moves underneath, the ice cracks, melts a little bit, refreezes, and you get these cracked ice patterns. That indicates there's something liquid underneath. If there wasn't liquid underneath, we wouldn't see this cracking and refreezing. We would probably see more craters from meteorite strikes, but we don't see that. So we think that there is liquid water up to possibly miles and miles, 50 miles more deep here. So where you have liquid water, you have to have some kind of heat to keep it liquid. And we know a lot of life lives in the ocean. So Europa is a pretty interesting place when you think about all that liquid water underneath the ice. What could be living there? Okay, another one that's a little bit different is Titan. By the way, these are all places that NASA would like to visit someday and get more information, actually land probes there, try to figure out what's going on. We have actually been to Titan, but we'd love to return. Titan is Saturn's largest moon. And it is pretty cool because it does have an atmosphere and it does have some of those organic molecules. It's not just water. So you can see in this picture here that it does have an atmosphere. The atmosphere is not like Earth. It is a lot of nitrogen, which is good, not so much oxygen. It is very cold there. It's far away from the sun. But it is interesting in that it has really interesting molecules. It is rich in our carbon-based molecules, which we call organic molecules. That just means that they are carbon-based. So rich in carbon-based, call those organic molecules. In chemistry, organic doesn't mean that it was grown without chemicals. It just means that it's carbon-based, which we know are really important for life, right, here on Earth. And it does have water. It is too cold for liquid water, but it has water ice, and it's sort of a rocky surface. Water ice on a rocky surface. Okay, so very cool place. You might look at this picture, look at this one. That looks like lakes and liquid water. It's not. It's too cold for liquid water. Those are methane lakes. Yes, methane, like the gas. It actually rains methane. There are methane clouds and methane lakes. Really cool place, Titan. Interesting place to think about what life would look like there. And our last one here is Enceladus. I like this one just because of its interesting name. Enceladus. So all of these moons actually are based on characters from the Greek and Roman myths. Many of them are named after Titans. Okay. Enceladus is a small moon of Saturn. And it is interesting because it has water and heat. It has, very much like Europa, this water ice outer layer that we think hides a liquid ocean. So water ice and liquid water. So it looks like Europa in that sense. It has one other sort of really cool feature though, in that we know that it's hot. We know that there's liquid underneath this ice because it has these water volcanoes. And so you see these jets right here? That is evidence of internal heat. Those jets are like geysers spewing liquid water out through the ice. So we call these cold volcanoes or cryovolcanoes. So cryovolcanoes are just basically water geysers. So we know that there's heat there. We know there's liquid water there. We've actually flown a little spacecraft through there to see what's in those geysers to look for organic molecules. Found some interesting things. No life yet, but it's another cool place to explore in our solar system. So let's end this section with a clicker question, sort of thinking about what we learned and what's good for life and what's not. So answer that, and I'll add a couple of videos too about those moons. See you next time.